Hello, we're going to finish off the last two questions, which are the problems for Chapter 1, Section 1.7. So the first one here is, if A and B are both even or both odd, what can you say about A plus B and A minus B? Well, it's pretty obvious that both of these are going to be even if A and B are both even or both odd. And that means this identity then makes sense because all of these will be integers. So I've got the sum of 4 squares is k times the sum of these 4 squares. I want to find the value of k. Well, this is meant to be an identity, and so if I just put A and B and C and D all equal to 1, then you'll find that k has to be a half. Given now that 1 squared plus 3 squared plus 5 squared plus 7 squared is 84, we want to find 42 as the sum of 4 squares. So I'm simply going to put A equals to 1, B is 3, C is 5, D is 7. And so that's going to be 84 here, and K is a half, so that'll turn into 42. And if I plug those values into here, then we end up very simply with 42 then turns out to be just 2 squared. So we take the average of these two, we get 2. This minus this over 2 is 1. The average of these two is 6, and this minus this over 2 is 1. So we get 42 is the sum of squares in that way. The last question, 27, is to show that a number of the form 16n minus 1 cannot be expressed as a sum of fewer than 15 fourth powers. Now we know that every number can be expressed as the sum of at most 19 fourth powers, but this gives us a family of numbers where you need at least 15 fourth powers to express a number of this shape. And again, it's fairly easy. You simply note that modulo 16, which is what you'd be looking for since we're looking for numbers of this shape, modulo 16, the fourth powers only look like 0 and 1 for any integer x. So if I look at 16n minus 1 and I want that as the sum of 14 fourth powers, then what can happen? Well, each of these numbers here is either 0 or 1, so we could have them all 0, in which case this would be 0. We could have 1, 1 and all the rest 0, we get 1. We could have 2 1s, the rest 0, we get 2, and so on. And the biggest we can hope for is all 1s, and that would give me 14. But that's impossible because a number of the shape 16n minus 1 mod 16 is congruent to 15 mod 16, and it doesn't appear in the list. So that's the end of that problem. And that's the end of the problems for Chapter 1.